This is Chris Cook with Spatial Integrated Systems.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, this is Chris Cook with Spatial Integrated Systems, your local Siemens PLM reseller. I'm here today with one of our CAM experts, Fred Lauzuz, to present the Siemens PLM CAM demonstration, Overcoming Manufacturing Challenges with a Model-Driven Process. Brian Drebelis with Siemens PLM will be doing the webinar. There's a Q&A box open at the bottom of your GoToWebinar screen, so feel free to type in any questions that you may have during the webinar, and we'll be taking down those questions, and we'll respond to those questions after the webinar. Thanks for your participation.
Welcome to today's presentation of Siemens NX Manufacturing Solutions featuring NX CAM. If you're looking for ways to increase throughput and maximize your competitive advantage, let us show you how. In the next 30 minutes, I will introduce to you some top industry challenges and how NX offers effective solutions to achieve both your business and manufacturing goals to increase your competitive advantages. Manufacturing challenges, overcoming inefficient processes, accelerating production, increasing throughput to be more competitive, and achieve reliability, getting it right the first time. We will cover the following manufacturing challenges in this presentation. Now, let me go into more detail on these challenges. I will show you how NX CAM addresses each of these challenges. The Siemens Advantages. A model-driven process that's maximizing the value of a unified system with innovative technology for the greater productivity through automation and having solution confidence to support your business with a proven system. Now, let's look at the model-driven process with NX. Let's learn about the model-driven process. In NX, we call this the master model. Master model enables users to have a single model that's used for all downstream processes, from drafting, tool design, and assemblies to NC, CNC programming, and more. Product manufacturing information, PMI, drives automation of the programming of inspection and documentation, along with CAM programming and feature recognition. Workflows are done in parallel and concurrently, thus reducing manufacturing engineering time. All users and consumers of this information are kept up to date, seeing the latest progress and our changes in the work because of the full associativity in NX. There is no need to manage multiple copies of design models or to use separate software for different work tasks. Engineering change orders are seamlessly handled. All documentation and programming is updated from the single driving master model. This factor alone saves time and money, eliminating the issues like the part was programmed to the correct revision but was rejected by inspection because their documentation was a revision behind. Jim Sutton of Minco Tool and Mold stated this about Master Model in NX. He says, Master Model enables a design change to propagate through the tool design into NC programming. It ensures accuracy through the entire assembly, knowing that the finished product is what the customer has ordered. And this really becomes a powerful statement about the ability to help drive one's business to make sure we have accuracy in all and everything we're doing, from part pieces, design, and models, to the accuracy of delivering the product that the customer has ordered. Here we see the master model in a workflow diagram. You can see that we start with a design model. This design model is used in many processes as shown here, from the design stages and early preparation of job setup through the programming tasks all the way to the shop floor. I will show you the master model preparation and job setup portion next, covering the concurrent workflow that we see here. Model preparation and job setup in NX. Here, you can import or design your CAD model. NX reads all common CAD formats. We're going to select the CATIA V5 format. It's just a Windows file open, And here we'll see as we convert and load the part directly into NX, seeing the CATIA model. From here we're going to create a sketch plane and model the work holding and fixtures, creating the construction geometry that's used to build that fixture. We'll start with just a simple rectangle defining the outside border or the footprint or pad for the fixture. Again, with constraints and dimensions you can size and shape the geometry as necessary. Here we're selecting the edges or features of the part that will be used to create the containment boundaries on the fixture. This ensures that the fixture will always be associative to the part geometry. You can create fully defined sketches using the CAD tools in NX, as here we're adding additional geometry defining our design. You can create geometric rules that also assist in your design. Here we'll make all these lines parallel to the other sides of the fixture. Modeling the base and the mounting plate of the fixture is simple. It's just in the context of the part. We just select the part, and we'll select Extrude, and we'll just pick a face onto the part. This would be the mating face where the fixture would align to the part. We'll then select the top area, creating the mounting plate for the part. From here you could go ahead and add other fixture components to the part. Like here we'll add a bolt, right, that will be used in our finished assembly fixture or our inspection fixture to do that. Again, you can add additional clamps and fixtures using assemblies and components. So here we'll turn these off, and we'll continue on with our design using synchronous modeling to create the stock model for the manufacture of this part. Here we'll select the entire part and close all of the hole openings on the part. Again, we'll then offset different regions and boundaries of the part, representing what the casting stock would be from an investment cast part. Here we'll see a synchronous model can directly edit all the imported CAD model data. We'll add stock to the boss areas, change the blend radiuses on the part, and remove some of the other features or defeature the part into that. Add draft angles, etc., and continue modeling the stock model of the part. Here we continue modeling the second fixture for the part. Again, a similar operation as the first, we'll just create our sketch for a part, defining the areas of the fixture we need to create. We'll select the edges of the geometry again to remain associative. There we select the geometry. You can see the ease of modeling with inside of NX to create the fixture. Here we will move some of the clamp components. You can again see the ease of the dynamic repositioning of components in NX. From there we will create the fixture setup drawings for the shop floor. Again, this becomes a vital important when jobs are created, is to have this kind of documentation quickly, easily, and readily available associated to the part. Preparing product manufacturing information with PMI, again, is easy just by attaching the geometry the same as you would in any sketches or dimensioning onto the part and creating the drawing, thus defining the product manufacturing information and feature control frames. Here we see the finished drawing being created for the inspection operations. There we move into and you see a finished job preparation has been completed. In design model, 2 fixtures, 2 stock models, in-process drawings, inspection drawings, etc. Accelerate your production with NX. We have just seen how NX is used to increase your manufacturing engineering throughput in the job setup and preparation and tasks we all commonly use. Having the ability to create associative stage models and stock and casting models from a customer-supplied design data ensures reliability and the confidence that you always have it right. The inspection and quality department preparation and the fixture needs were handled, and the process documentation and drawings produced all concurrently from the one driving design source, enabling accuracy and communications throughout the entire job cycle. Let me tell you more about the master model workflow. Let's move to the CAM and CMM programming tasks. Here the work that was done in the job prep and setup is used by the programmer and programming departments to apply the tool path and our inspection paths. I'll show you this next. Programming the setups and operations in NX. Adding the part and the fixture to the CMM from our previous model preparation is fast and easy. Simply open the part, and add it to the machine tool. Dynamically adjust the fixture components. Here we will align the clamp to the mounting holes on our CMM. You may use constraints to center this clamp on the table's hole position just by selecting the edges of the clamp and a hole position. Using the PMI automation begins by linking the PMI on the model to the part. We select the SPM 600 probe, and we automatically have recognized the features, the measurement dimensions, and locations for the part. The inspection paths are also seen in the inspection navigator. We verify the inspection paths of our part with simulation, and to modify a path, we simply double-click to change any of the settings. Here we'll look at the point set and change them from 8 points to a 6x6 grid. Fast and easy programming at NX CMM. Let's look at what CNC programming department has been doing while we were over in inspection. First, set up programming the part and the fixture is mounted to the machine. NX-CAM machine simulation verifies the programming and the material removal. Here we see NX-CAM simulation verifying our 2.5D volume-based milling. We continue on with additional program features with easy-to-use 5-axis milling contouring around the bosses of our part. We then go in and we can look at swivel milling in 5-axis of the boss lugs on the part. We'll continue on with additional operations with 3+2 milling and multi-axis support by finish profiling the rest of our part contours, thus completing the first setup of this side of the part. Additional hole milling is fast and efficient in programming inside of NX-CAM. Next, we'll look at the second setup. The programming begins here with face milling in the second operation. Cut and rapid traverse across voids are all program options inside of NX-CAM's toolpath. Material removal and verification is standard in NX. Pocket floor and cleanup and helical Z-level wall machining is shown here. Here we'll continue on with that boss, finishing the second boss, and then moving on again to finishing the holes in the second operation of our part. Rotating and repositioning to do the second one with our spiral helical hole milling. Hole milling continues on the rest of our part to completing our part until we do our outside contour with multi-axis contour profiling. Let's look at how post-processing is done in NX. Here we select the desired post-processor in the desired control format. Quickly and efficiently, NX creates the posted output. Let's take a look at how this posted output next would be used in shop documentation. Shop documentation is standard in NX-CAM, and we create HTML formats of each operation and operations sheet. Tooling sheets and operations sheets are also used in shop documentation. Again, a simple click and pick creates this documentation in seconds. The job is now ready to go to the shop floor. At this point, the work is ready to enter the shop floor production phase. We have just seen a completed manufacturing, engineering, and programming workflow process. We've seen how NX technology enables faster throughput with automation, intelligent features, and streamlined interface. All along the way, we use the resources of tooling, fixture, machining, post-processor, and simulation libraries in NX. It is with this capability that NX captures and reuses your manufacturing knowledge and practices to drive your production with consistency of output and reliability that's right the first time. Here we'll use NX to simulate what will occur on the shop floor in this demonstration. The part has been machined. Now it's time for the first article inspection process to begin. Let's look at what CMM programmer had completed while we were in the CNC department. You can see the inspection paths now have been selected and are completed. Any modifications made. We'll now go back and simulate what is happening on the shop floor inside of NX CMM. So here we'll see the inspection paths come down, do the locations for our holes on the side of our part, and then we'll be deprobing are rib and pocket locations. Again, you can see safe repositioning of the probe to measure the rib locations and thickness. The manufactured part is now complete. It passed inspection. You're in production now. All completed manufacturing cycles were done using NX. The wait, engineering change notice. How much time and effort will it cost you? Will there be to redo all the engineering and programming time on the first article production? ECOs with NX are an everyday challenge. It's simple, it's fast. We'll take a look at what has changed. We'll look at the hole locations, the rib locations, thickness, and corner blends all have changed. NX maintains the associativity of these updates and has updated all the documentation drawings and inspection drawings. The drawings you see have reflected all of these changes. Next, we'll review the impact the ECO has on the CNC programs. As you can see, we opened the part, and the part files in the Navigator have been marked invalid. They need to be updated. Changes to the toolpath were marked. We select Generate, and the new processes are simply updated and used for your verification with simulation to approve their changes. We'll continue on looking at all these changes that are going on with our part. Next, the user will select and view the toolpaths of each maybe single operation he would like to review. We'll now look at what happened to the CMM program and verify those ECO changes. Again, we see the model has changed and the inspection paths. Again, we go back, use simulation to verify that, to have the confidence in knowing it was right the first time. Again, we will go back. You'll see the pocket and the rib locations have moved along with the thickness. Fast, efficient ECO handling with NX Manufacturing Solutions. The Siemens Advantages. We just have seen the advantages of the model-driven process and how NX can decrease your time spent in manufacturing, engineering, and programming departments, bringing consistency and confidence with your manufacturing workflow and processes. Next, we'll look at NX CAM's innovative technology in toolpath and job programming. We will see how productivity is increased through NX automation. Innovative technology. The toolpath is created with optimum tooling and cutting strategies to reduce programming time by eliminating lengthy geometry selection and preparations necessary in many CAM systems. Productivity is increased with intelligent toolpath generation by NX CAM's knowledge-driven tools. NX CAM's 2.5D volume milling saves programming time with built-in intelligence, resulting in not only programming time reductions, but time-saving material removal, all while keeping it up to date with master model to give you even more time-saving power when ECO changes try and slow you down. Let me show you how. Let's take a look at an industry example of the company Telsmith. They're involved in the industrial machinery and heavy equipment marketplace. Their business challenges were to increase their CNC programming output and improve NC machine productivity. Their results with using NX CAM were more CNC programs were generated in 3.5 months using NX CAM than in the previous 9 months using another system. NX generates more programs in spite of being used to program more complex machines. What Michael Weir had to say is, we're measuring our savings not in the minutes or hours, but in the number of shifts we save. NX innovative technology. NX can increase your efficiency in turning, milling, drilling, multi-axis, CMM, documentation, and more. Many products need to be manufactured with multiple setups across multiple machine styles. We've seen how Master Model ensures that we have the correct data all the time. Now let me show you in more detail how NX CAM can drive productivity and time savings in your business. Complete programming of a machinery part will be demonstrated here. Here we'll take a look at this filter head part. We will start with the turning setup in NX CAM. Notice we have a workpiece setup. We define our workpiece, our stock, blank, and fixture components. Along with that, we will identify the blank, and we will select the materials from the material library that this part will be manufactured from. Here we'll select aluminum for our part. From there, we will go back. NX automatically creates the spun outline for the lathe cross-sections that's used for programming. There we can see them outlined for us. Next, we'll look and see how to create toolpath operations in NX. So we can select. Here we'll take a look and use the facing operation for our part. We'll select our part, and it's as simple as just selecting the cut region or the cut face we wish to use. Again, we can grab the tool, dynamically zoom in, take a look at that, and simply press Generate. At that point, we understand the volume and size of the stock. We created the facing operation. We'll create our second operation for roughing. Simply press Generate. We understand where the stock volumes are. No additional picking necessary. Here we'll see 3D material removal and toolpath verification of the two toolpaths we have just programmed. We will continue on programming our part with the rest of our features, grooving, finish operations, etc. Here we'll take a look at what the programmer has done with that. We'll replay this again with verification with material removal. We see our facing operation, our OD operations, followed by we'll have our finish pass, grooving cycles to complete our part, along with the boring or drilling of the large hole in the center of the part. Second machine setup is drilling, if this part was done in a conventional manner across 3 different machine tools. NX setup assures reliability with machining by the use of assemblies. Here we use feature-based machining to automatically program the holes of the part. Feature-based simply select the part and select the desired type of features we are looking for. You may filter them just separately or find all features on the part. Here we will unselect grooves and we will just select the hole operations on the part in this demonstration. So with this, it's simple. We select the option for holes, and we ask it to find the holes. We see NX is finding the features, locating them, and there we see that we have found over 60 features, or hole features, in our part. It is quick and easy to just select these features to have them automatically programmed with the appropriate tool size and operations for that feature type. Here we would have our drilling operations, our spot drill operations, center drill, chamfering, and our tapping operations. Let's go ahead and take a look at the verification of these program operations. With this, we'll simulate the part, we'll zoom in, and we can see where our first position for our hole location will be. Then we will just select play to watch our program operations be simulated as they would be machined on the actual machine tool. We'll continue from spotting and on to finish drilling in our operation, thus completing the second setup for this part path. We would continue on moving into our third setup, which really involves the finish machining operations on the head of the part. Here we're using horizontal machining with our multi-part programming. 2.5D volume-based milling keeps track of all the impressed stock across multiple machine parts. With NX, it is only necessary to machine or program one part, and all the other parts, regardless of orientation, are simultaneously or automatically machined. To make a change, it is quick and easy. It is just select the operation, double-click, and make the selected changes. Multi-part programming is standard in NX CAM. This would complete our standard machining operations of turning, drilling, and milling. Multifunction machines reduce setups and increase productivity. Multifunction programming requires only one setup in NX CAM. Here we see synchronized toolpath on the main spindle for turning the main body of our part. We continue on with the boring of our part, finish toolpath, and grooving operations. We will continue on by drilling on the main spindle and milling operations on the sub-spindle, continually programming on the end of our part, creating the part contours, relief areas, and holes on the head of the part, while we're still drilling 60 holes on the main spindle, thus saving valuable program and machine time across multiple machines. Here again we can see is the tool path verification, some chamfer milling operations going on. Now we'll finish the face milling on our part, moving on to do some 5-axis machining inside of the small cavity on the top of our part, all while still drilling our 60 holes. 5-axis milling, again, is simple and easy in NX CAM. Here we'll see our contour and contour profiling operations in that tapered wall cavity. There we have it, a 5-axis mill turn part, all completed inside of NX CAM multifunction machining. After completing the first part, we moved to the finish inspection operation as we had seen before in our aerospace style part. So we see all of our inspection paths that we had selected, utilizing the same features of linking our PMI programming on the part. The CMM programmer may make some desired changes, as we've seen before, changing the size or number of points or contact points that are used. The easy-to-use interface allows quick, rapid changes inside of NX CMM, all with the power of NX, milling, drilling, turning operations. Whether standalone machines or multifunction, they're all done fast, efficient, and easily with NX CAM. The Siemens Advantages, solution confidence. We have seen master model, NX CAM, NX CMM, shop floor documentation, and all in a concurrent workflow, showing how innovative NX technology can enable your business to grow and be more competitive. Let me show you more detail on how Siemens manufacturing solutions are affordable, right-sized solutions for your business. There are 3 major components that contribute to the manufacturing reliability and the confidence that you get it's right the first time. They are an integrated, associative manufacturing environment that brings it all together, from CAD, CAM, CMM, all the way to the shop floor, and having scalable solutions to match your business needs at affordable costs. Let us show you how affordable an NX solution is. You can start with a value price package or a point solution for turning, milling, etc., and always have the confidence that you can add the capabilities as you grow and your needs change, all the way to fully managed manufacturing, shop floor, simulation environments, along with the staying power of a major manufacturer, Siemens, an established vendor in the manufacturing marketplace. Let's look at an example of a larger company that has used all of the Siemens products. Fuchs leverages an end-to-end product development solution from Siemens PLM to streamline the development of large complex machines. Their solutions include NX, NX CAM, Teamcenter, and the Siemens 840D controller. Whether your company is small, medium, or a worldwide manufacturer, Siemens Manufacturing Solutions is right-sized for your business and your future. Let's watch and listen to what one of our mold and tool companies have to say with their success with NX.
Benco Tool and Mold's primary business is building plastic injection molds. We've been in business for over 50 years. Our competition isn't the company down the street. Our competition is the world marketplace. We were an early entrant into CAD/CAM, where we found a niche in the marketplace, whether it be just general machining or it be in the mold making part of our business. It is complex shapes.
We always strive ourselves in the quality of the tool that we take to press. We use NX to maintain that quality. A customer comes in with a concept sketch that he wants to manufacture, he wants us to mold. We're able to take that napkin sketch, turn it into real product using NX. NX gives us the tools to engineer our designs up front, whether it be a product design or a tool design. We want to make sure that we go through all aspects of the part and the tool early on in the process. By doing that, we know that when we start cutting chips that we're actually cutting what we want. or not duplicating efforts. So it's important for us to maintain that accuracy through the entire process, and that's what NX gives us.
We get a supply file from a customer, and we'll take it in here and we'll redraft it and make it toolable. Basically, I will wrap steel around that part and make the mold base that will produce the plastic part.
NX is a strong modeler where we can bring in data from multiple sources. The ability to manipulate complex geometry is easier to do inside of NX because its ability to deal with explicit models, hybrid models, or fully featured models. We're not limited by the software in order to develop our product.
Synchronous technology helps in the way you can manipulate geometry easily. You can go in there and remove faces, delete faces, simplify bodies quickly. You don't have to worry about parameters. You just go in there and delete or change size. That is a Mold Wizard component. We drop that in. It automatically knew to hook into the ejector plates down here. All we did was put the part area on it by wavelinking in the part geometry into the lifter file and then trimming it off. And if we ever update that part, that lifter will update automatically.
We allow that master model then to propagate through the tool design into programming, where tool design will go in, update their model. Programming then will go in and update their data, their tool paths over top of the existing tool data. That's going to ensure that we keep accuracy through the entire assembly, knowing that the finished product we get out of the mold will in fact be what the customer initially sent.
We program 100% of the model using the CAM software from NX, and then we do all our trode modeling, everything through NX, so the finished product. The master model is very important because everybody's on the same part at the same time using the same model. Everybody's looking at the same thing all the time. Everybody knows how to dimension, verify stuff. You don't have to teach 3 or 4 different software. So if everybody's synchronized on the same software, everybody can help each other. You got to save time, you got to save money. So we implement the high-speed machining whenever possible, small cuts, light cuts at fast feed rates. And yes, NX has several options that you can adjust your paths accordingly. There's options in NX that will actually turn the corners, which actually creates a much nicer and smoother path. It doesn't have the jerkiness of the machine.
It's faster, it's better quality. Now you just set it up and away you go. Sometimes you may have 12, 14 inches, and now we can cut that in half, which means better rigidity, better part finish, better tool life. Sometimes I'll run 20, 24 hours for a finish cut, but it requires no polish. And you have to have a very good software to do that. We start in product with NX, we design in NX, we program in NX. So what you see is what you got. I mean, that's just that accurate. It's that good. And without it, we wouldn't be in business. I mean, it's pure and simple. I mean, if you're not your guy cutting fast, you're not making money. If you really want to cut a true part form and cut it accurate, you better have it all today, because the pricing isn't there anymore. It's a world market. It's serious business.
NX is an important product to us because it is an integrated product, and that's what we're about. We don't just design the part, we manufacture the part. So it's important to us to take it all the way through in the same software.
If we maintain accuracy both from product design, tool design, programming, through the building of the tool, we're going to ensure that we maintain a level of accuracy that gives us a high-quality part.
Time and cost somewhat equate. If you can't beat them on labor cost, then you've got to find a way to beat them in some other way. And that's where we excel and always have excelled, is that not only do we do things in a hurry, but we do it on time.
Siemens Advantages. Our time is drawn to a close. I'd like to emphasize the advantages your business can have with the Siemens Advantage of the model-driven process to maximize the value of a unified system, for innovative technology for greater productivity through automation, and solution confidence to support your business with the proven system and the staying power of Siemens.
At this time, we'd like to answer any questions. Let me see here. It doesn't look like there are any questions at the moment. So we appreciate your time for attending. If you do have any questions, you can give us a call at Spatial Integrated Systems. We'd be happy to help you out. Thank you very much for your time today.